All right. This next speaker is it's a special speaker, and I'll let John explain why. Tell me about our next speaker and what makes him special for us.
Oh, absolutely. So BitK is coming up next with a talk. He is an avid Capture the Flag player. Right now, he is holding the #1 spot on the NahamCon Capture the Flag, the CTF that's going on right now. So we got a few more hours if you guys want to challenge him. Hopefully you can catch him, break that lead. But he is an avid Capture the Flag player, and he's going to introduce us with an incredible talk on pwning a new machine. So without further ado, here's BitK.
Hello everyone, and thanks for having me. I'm here today to talk to you about my new project, the Pwning machine. And because probably most of you don't know about me, I will start with a quick introduction about myself. My name is Lucas, or BitK. I'm a French bug hunter and security nerd. I've been playing CTF for almost 10 years, first with the French team Expresso, and now with the team the Flat Network Society. We are currently playing the NahamCon CTF, so I hope we are doing well. But I'm also an event organizer. I've wrote the Spooky Challenge in 2018 and the CTF for Hack in the Box in Singapore last year. 3 years ago I started doing bug bounty a lot more. I was mostly hunting on the French platform YesWeHack because everything is in French and it was easier for me to be able to explain myself with program managers. After a while, I managed to climb in the top 10 of the platform, and YesWeHack invited me to a live hacking event where I was able to meet the team, and after discussing for a bit, we decided to work together, and I'm now working as a technical ambassador for them. Enough about myself, let's start talking about self-hosting. But first, let me tell you why I want to talk to you about this subject. The way we build application has drastically changed in the last years. What it used to be, it was a simple architecture with a web server serving static page or maybe some PHP with a database and some cache server here and there. So when we were looking for vulnerabilities, you were looking mostly on common injection or maybe XSS on the front web or maybe some injection on SQL or LDAP or any other query language, and maybe some weird interaction between the cache and the web server. Everything was pretty simple, and when you found a bug, when it was triggering, it was pretty easy to know where and why. But the web has grown since then, and now application looks more like this, where you have a load balancer talking with loads of microservices, some rendering, some API, databases, firewalls, every kind of stuff. And with an increase of services, you also got an increase of communication. All of those small nodes communicate with each other, usually with HTTP, but not only. If you are wondering why SSRF is becoming the most popular of high-paying bug, this is exactly why. The increased number of communication also increased the attack surface. With this increase of attack surface, it could be difficult to know where your bug is triggering. Maybe you have something on the API, but maybe it's triggering way in the back on the renderer, or even on the database. And also, as I say, in all this communication in between. And the bug can be catched anywhere in this communication. That means even if something triggers in the back, you don't even know it's triggering. So how do you detect that an exploit was successful? Usually you use callbacks. You make an exploit that once it succeeds, it will call back to your server so you can detect the exploitation. If you're looking for SSRF, you have already probably used Bob Collaborator that will show you all the callback done on a URL. It will generate a unique URL, and with any query on it, whichever the protocol is, it will show you what happened. So if something triggers here, that means a request was done. If you are more interested in client-side bug, you might be looking for blind XSS, and XSS Hunter seems to be the most popular one between bug hunters. I can also talk about other kind of hosting, like if you need to upload a file, you can use GitHub Pages or maybe YouTube to upload a POC of your exploit. Maybe Imager, or sometimes I've seen some pastebin with some POCs in some reports. All those tools are great if you want to quickly start hunting. You just sign up and everything is working out of the box. And it's simply work. It's not like a homemade script that work one time and you need to write again for a new exploit. Everything works fine, you just register and let's go. And also you got a community around these tools. If you need some help, you can just post on Twitter or on some forums and you get help because people are used to these tools. But all those tools come with a cost, and the cost is trust. You need to put trust in all the people involved in the loop. From the developer of the application, to the people managing the application. With the hosting company, do you trust where the log are stored, where the backup are stored, and also the law in the country where the service is hosted. Another issue with third-party services is decentralization. All those bugs come to the same place, and this is a juicy target for Black Hat. What if you can control the server running XSS Center or Burp Collaborator? You could have access to all the bugs first, and you can use them before they can be reported to the companies. And why I think these services are well protected, I think having a single point of failure is very dangerous. Self-hosting could be an obvious solution to this kind of problem. If you have multiple nodes of the same service, there is no single point of failure anymore. So why do hackers do not just simply self-host? Is it because they do not care about privacy? I don't think so. Hackers are very well educated about privacy issue. If you go to hacking convention, you will see people with stick-ons and telling others that they don't want their picture to be taken. And I met a lot of people without any Facebook or any social media accounts because they don't trust them with their private information. So why do you trust someone else with your bugs? So this is not about privacy. Maybe is it because it's too difficult? Maybe it's not possible to host two services. But no, like you can just go on GitHub and download XSS Center and put it in a Docker somewhere. Or you can just use the Burp Collaborator Java file and host it on another server. It's doable. It's not easy, but it's doable. So if I care about privacy and if it's clearly possible to host all of this stuff, why are they not doing it? Is it because they are lazy? No. Once again, I don't think hackers are lazy. Just look at the grinding some of people are doing to submit bug every day. Hackers are not lazy. So if it's not any of this, why do hackers not simply self-host? First, I think it's very time-consuming, and you probably think you have better thing to do. Like you don't want to spend days on setting up a web server and your DNS and your SSL connection, because you are too busy finding bugs. So if finding bugs is what you like to do, doing admin sys is probably boring for you. It's not interesting at all. You just want something that works, and that's all. Last thing is, it's not a one-time thing. Once you set up your server, you need to keep it updated. You need to be sure it's still safe. This winter, I decided to change my whole server for a new one, and I wanted something that was more easy to manage and to update. And so today I wanted to share with you what I came up with. So this is my new project, the Pwning machine. The goal of the Pwning machine is to have something that's easy to set up, fast to set up, and easy to manage for hunters. So let's take a look at how this works. To start running the Pwning machine, you will need only two things. One server running Docker and a domain name. Once installed, you will get access to a DNS server answering for your domain name, a traffic reverse proxy that will make the communication between all your sub-services and the web. It will also be in charge of managing your SSL certificate, and you also get access to a pipeline runner. I will talk about this later. The first thing the Pwning machine offers is a web server. You always need a web server because most of the time the service you're attacking are communicating in HTTP, and you want something that talks HTTP to talk with them. The server uses PHP to run some codes because it's the fastest way to have web page running without setting up a lot of stuff. The server answers to any subdomain, so you can do whatever .yourdomain.com, it will work. How it works is the subdomain will be mapped to a folder, so if you want to create a new subdomain, you just create a new folder and the subdomain is created. Because I use traffic and power DNS, all the SSL stuff is already undone for you automatically. You don't need to set up a new certificate for every subdomain. Also, the Nginx server comes with two special folders. The cores folders, which will always answer with valid cores headers. It's very useful when you try to do client bug and you don't want to set up a new one every time. And the public folder is just like another subdomain, but you get directory listing. So if you want to share stuff with the world, you can just put it in your public folder. With Nginx, I also choose to add 3 basic servers in the core of the Pwning machine. The first one is request bin. It's a very useful request logger. You can just create a request bin on your server. Here you can see I'm on requestbin.bi.tk. It will give me an URL. And if I decided to curl the URL, I can see the output here. It's basically like a web collaborator, but it's running on your own server. It also supports the file upload and stuff like that. The next one is request bin. It's an HTTP request debugger. It's very useful when you are doing SSRF request and you want to know what exactly the kind of request you receive. If you only look at your Nginx log, you will get the method and maybe the get parameter, but that's all. So here you can just create a new bin, copy the address, and submit it as your exploit. Here I will just use curl to make a demonstration. So I can curl this URL. Let's put some data, maybe. And we get to OK, the request has went through. And if you look here, we can refresh, and we got the full request with the post parameter. This is very useful for HTTP requests. It will replace the web collaborator for HTTP very easily. The next service is a transfer.sh instance. This is a file sharing software. It's very useful when you have to share a file for a report or just for an exploitation. You can just upload file and download them, but why I choose this one is because you can use it very easily from the command line. For example, imagine I'm on a remote server and I manage to do a curl command. I can just do the upload file. Let's upload my etc password to my server. So https://transfer.bi.tk. I can choose the file name like etc/wd demo. The file will be uploaded and it will give me back a URL. And I can just visit to download the file. But what I like a lot about transfer is you can just wget the file and it will work instantly. It will detect you as an agent. So a very good way to transfer file between servers if you are a very heavy command line user. And the last tool is CodeMD. It's a Markdown editor. I use an online editor instead of local notes because when I'm doing collaborative bug bounty, it's easier to have something where everyone can edit at the same time. Also, the Markdown support is very powerful with CodeMD. That means that at the end, when you have finished to write all your notes on your pen test, you can just submit the report directly to the platform and it will work just like that, because nowadays all the platform I know use Markdown as a way to write reports. So let's get started and let's see how to use the Pwning machine. Here I've cloned the Pwning machine repository and I've edited the config file. Since the Pwning machine is heavily based on Docker and Docker machine, you will first need to set up a Docker machine. It's very simple. And then you specify the Docker machine in your config file. Here my Docker machine name is bitk. I will configure the host name I will use because everything will be based on this. Also in the environment, I set up my server IP, but that will be useful for the DNS. My host name once again. Here I use a reference from YAML. Some configuration for API, not important yet. And the services I want to run. Here I will run Nginx, PowerDNS, Traffic, the pad, the request bin, and transfer. And at the end, this is the HTTP configuration. I want to serve HTTPS for all subdomain on Nginx on port 80 and on request bin and the pad and transfer. These are the subdomain I used before, and this is the service they are talking to at the end. So let's get started. Here in this folder, I've cloned the Pwning machine repository and I've installed the PM client. I've also already configured Docker machine to communicate with my host, bi.tk, and I've configured the config file. I've put the Docker machine here, the hostname I want to use, and some environment variable, the service I want to start. These are the core services, and the rules for the HTTP. So each service is bound to a container and a port. And since managing and remembering a lot of Docker command is time consuming, I've built a simple command line tool to help you work with it. So let's start the Pwning machine. It takes around 5 to 10 minutes to install everything. Here I had to do it on 3G because my internet broke during the recording, so it takes a little bit more, so sit back and enjoy. Just kidding, I won't let you watch the whole process, but at the end you end up with something looking like this, with all your services running. And you only had to put your domain name and your Docker machine name. Now that everything is ready, let's take a look at the Pwning machine command line tool. So you got a simple command line tool with a syntax inspired by Docker, but it also provides extra command. Like for example, one thing you often need to do is to change something on your server web. Instead of SSHing to your server, what we will do here is just use SSHFS to mount your container volume inside your host here. So keep in mind everything is running in a Docker on a remote server. But I can just use PM mount. I want to mount my web root. I need to wait a bit. This will mount the volume on your computer and you can access all the file like on your own computer. That means you can use all your editors or any software on your computers to edit the file, but the file will be edited on the remote website. For example, I got these hostile folders in my web server. Keep in mind that each folder matches a subdomain. If I want to create a new subdomain, I just need to create a folder. In these utils, I got a redirect script that do a simple redirection. So let's edit it. Just to put a friendly message at the end. Save the file. And now we can just check the file online. Here I'm on utils.bi.tk/redirect.php and I forgot I put the memtip as text, so here is our text as a string. But it's simple as that. You just need to mount your web root, edit your file, and save. And when you close the shell, automatically the folder is unmounted. Now that you know how to modify files on your containers, but how about getting access to the logs? Pwning machine also offer you a quick access to the logs. For example, I want to know what's happening on my Nginx server. I can use the log command. The -f is just the follow command, just like on Docker. Once again, I need to wait a bit. Yeah, I got a live stream of what's happening on my server. Let's do a simple request to test that everything is working. I use HTTP to do this. Post https:/.bi.tk. Let's use a weird domain name, like weird /test, and we can see it happened on the logs. So just like that, you have the log. To stop and start server is as simple. For example, if I don't want to use transfer anymore, I can just do pm stop transfer. I got auto completion on the command also, but it's faster when you're not on 3G. So let's stop transfer.sh. It's done, so it's done. So let's check if transfer is still on. Transfer.bi.tk, and I got a 404 because the service is down, and by default it will fall back to Nginx since the folder doesn't exist. We got a 404. So let's start the service again. this time with the start command. And everything should be back on in a matter of seconds. Okay, let's go again. And it's back on. So it's very easy to start or stop any service. Starting and stopping services is fine, but even systemd can do it. So let's try to build a new service. Let's go to the service folder and we make, oh, you can see I've already got extra services on my own website. But let's make a private bin service. I want to be able to use my server as a pass bin. I create the private bin folder and I need to create a Docker file, a Docker Compose file. Here I specify the version I want to use. I use the same everywhere as for compatibility issue. And I define my service. I will now name it private bin. As an image, I will use the official image. And I will connect it to the network traffic because I want it to be accessible from the net after being went through the proxy. Everything seems fine. I just go back and edit the main configuration file. So we need to add the new folder we created. We called it private bin, and we want to create a new domain to expose the private bin. I will create the past subdomain. It will connect to the container private bin on the port 8080 because this is the default port for private bin. Everything looks fine. We just need to save and to run. First we build the service, so pm build private bin. It should be pretty fast. There is almost nothing to do because it's just a remote image, and we can then start the service. Pm start private bin. Wait for the clone of the image, and it should be working right now. So let's check this. I say past.bi.gk, and here it is. It's running with HTTPS, with Let's Encrypt, and we can start using it right now. Perfect. So it's very easy to build new services on top of the Pwning machine. In 90% of the cases you will only need to use the pm command, but some of the time you want to go in the Docker internals, and you can just do this by loading the Docker machine with just pm env. It's slow again, and once you're logged you can just use classic Docker command to see what is actually running and list the volumes and everything. Let's go back for a bit to our overview schema. So we know how traffic, power DNS and all the services work together now, and how easy it is to pop a new service inside the containers. But let's take a look now at the pipeline runner. When you do bug bounty, you often do the same task over and over on multiple domains. When you do recon, for example, you always start with some DNS enumeration. After that, you might want to do some directory listing, directory enumeration, or even some screenshot of each available web page on a server. And it's always the same thing. Since I don't want to do the same thing over and over again, I wrote a script to do this for me. And because this is not the only kind of pipeline I want to do, I wrote something that is quite generic, and you can build your own pipeline with it. You might ask, what is a pipeline? What I call a pipeline is a succession of small containers, ephemeral containers that will be only run once, that do a simple task and output the result of this task in a file or somewhere else. And a next container is popped, get the output of the first one, do something else with the data, and pass it to the next one, etc. Think of it like a succession of common on Linux with pipes between them. And because a demonstration is always better than a long explanation, let me build a pipeline with you. Our goal will be to make a pipeline that will enumerate subdomain for a given hostname and fetch all the subdomain that it found. So let's edit the config file. I've here created a pipeline, so I will put it in another folder called pipelines. I'll call the file demopipeline.yaml. In this pipeline we will have 3 services. The first one will be amas. It will take as an argument an hostname. The next one is wget, and the last one is copy to web. Because I want wget to output in the folder, and I prefer to have small services since I will be able to reuse them and reorder them as I want. The whole pipeline takes as argument an hostname. This will be useful for autocompletion and validation of the command line. And now let's create each service definition itself. So let's go to the pipeline folders and let's edit the demo pipeline. First service will be amas, fetched directly from the official image, and as a command we will simply run the basic passive enumeration. So enum and the hostname fetched from the command line. Then we'll put everything in a folder called data in amas.log, for example. We want the data to be available across all containers running in this pipeline, so I will mount this data as a volume. We'll create a volume called internal and mount it to data. Don't forget to create your volume here, internal. Amas will create a file with a DNS entry on each line, and we need to process it. So let's create a wget container. As an image we will use alpine, and as a command we will do the following. First we will read all the file, all the domain name in the file. So rail read line do wget the line, and we will output it in /data/output/ line.html. Done, and we will do this with /data and amas.log. But first we want to be sure wget is installed, so apk add wget and the whole command. Like before, we want our data to be matched to something, so let's put the volume, let's mount internal to data, and this should be ready to go. And in the end we will have a simple container that will copy the output folder to the web root, for example. Let's go copy to web. We use a simple alpine once again, and the command will be cp.data output to /webroot output. And as the volumes we will need the internal one, mount to /data, and the webroot mount on /webroot. So we need to specify where the webroot is coming from, and it's coming from an external source, and the name is webroot. I've made a small mistake here. I need to use a $$ because I don't want the $sign to refer to Dockerfile variable but to bash variable. So this should be good. Once everything is ready, you can just run pm pipeline ls to see a list of your pipeline that you have already defined. So we see our pipeline, DNS and fetch. It will use amas service with a hostname variable, pass it to wget and copy to web. Now we start our pipeline with pm pipeline start with our name, so DNS fetch. It will not start because we want the host name, so I'll put my host name in there. And the pipeline should be ready to go. We can check again with pm pipeline ps to see what the pipeline, to see the running pipelines and where they are currently. So we see the DNS and fetch is running and currently is running AMAS. So we need to wait for everything to finish to see the result in our web folder. You can also start multiple pipelines sometimes, so we have pi.k running, but you can also have, I don't know, google.com or another one on Facebook. And you have all of them running at the same time on different containers. You can still see all of them and where they are in the running state. There we are, all of them stuck in AMAS. Our first one is finished, so we can now look at the output in the weblog. So pm mount web root. And in the root we should have our output folders with all our .html for all the DNS enumeration that we have. So this is basically the pipeline. This look a lot like a CI from GitLab, for example, but this is more adapt for your everyday bug bounty life. So this was the Pwning machine with all the services and the pipeline runner. Because this is an online event, I will do the question and answer both by myself. So this is the question I thought you might have. The first one is it ready? Almost. I've still got some documentation to do and some testing to be sure you don't have your data erased with a command or something like this. So I need to foolproof it a little bit more before releasing to the public. So if it's not ready, when will it be available? And I think I will be able to publish first beta version in the next weeks. It will be available on the YesWeHack GitHub. You will be able to find the link on my Twitter, on the YesWeHack Twitter, no worry. The next one is how much will this cost? So the project is open source, so it will obviously be free, but you need to rent a server to host your Docker machine. You can use a virtual machine on your own computer, but it will be kind of pointless because you won't be able to validate the SSL and everything. So you will probably need to rent a VPS. I think around $20 a month should be perfectly okay to run all of this. And because it's so modular, if you want to have something more beefy to run more services, it's up to you. But I think with $20 a month, you can run this easily. And $20 a month, I think it's a fair price for someone doing bug bounty every day. The next question will be probably, what about Axiom? Because Axiom is another kind of self-hosted way to run your tools in the cloud, but it's a bit different from the Pwning machine. I think Axiom is more about when you don't want to install tools, you want to have everything available right away. So you just start up a container and run the tool in the container. With the Pwning machine, it will be more about having also a place you can call home, your own server when you can keep your blog on it, all your tools on it. So I think both of them are complementary. And I hope in the future, then when you are using Axiom, you can use the Pwning machine as a backend. So you can use the power of both tools at the same time. And finally, do I need some help? Yes, please. I'm the only one working on the project. If you want to take part in it, will be just by writing more services, by converting already existing Dockers to the template format. I haven't talked about it a lot, but I will need help with this. I will need help with testing. If you want to test, you can just contact me. I will put all my contact in the next slide, and you are more than welcome to help. if you want to stay in touch with the advancement of the project, you can just follow me on Twitter at BitK or at YesReact. Both of the accounts will tweet about the news. Thank you everyone for listening to this talk. I would also like to thank all the organizer and sponsor of the event. I'm very thankful to be able to speak here in front of you today. The video part of this project was a bit new for me, and I hope I wasn't too boring. I hope the editing was not too much, and I hope you can be able to help me in this project in the near future. See ya. I'm here today.
Wow. Okay. Seriously though, wasn't that mind blowing? I'm a toolist person, so I love this kind of things where you're kind of like self-hosting. Today, systems are being blocked constantly because your burp intruder or whatever thingamajiggy is getting blocked by WAVs. And just hosting your own domain is something that, is crucial today. And if you're not using your paid version of burp or you don't have a pro version, you can't just do that. So this is awesome work. If you're interested in partaking in this endeavor, sign into the QA over at the Discord like now and help BitK out. This is amazing stuff. I'm super excited to try this out in the upcoming weeks when the beta is being released to the public. Awesome stuff.